Alright, so let's dive into the fascinating concept of time dilation in the universe. Imagine, if you will, two twins. One of them stays on Earth, while the other travels into space at a speed close to the speed of light. Now, according to Einstein's theory of relativity, the twin traveling at such high speeds would actually age more slowly compared to the twin who stayed on Earth. This is because time itself is affected by the speed at which you're moving. It's a mind-boggling idea, isn't it? But it's been experimentally verified through various tests and observations. The faster you move, the slower time passes for you relative to someone who is stationary. So, in essence, if you were to travel through space at near light speeds, you could potentially return to Earth having aged only a few years, while decades might have passed here. This phenomenon has profound implications not just for space travel, but also for our understanding of the universe and the nature of time itself. And that's the beauty of physics. It constantly challenges our perceptions and expands our horizons. So, the next time you look up at the stars, remember, time up there might just be ticking a little differently than it is down here. Now let's dive into one of the most fascinating aspects of time dilation: black holes. When you approach a black hole, the gravitational pull is so immense that it warps space and time itself. Closer you get, slower the time moves for you compared to someone far away. It's almost like, time itself is stretching. Time is not a universal constant, it's deeply personal. Imagine two twins. One stays on Earth while the other travels through space at near light speed. When the spacefaring twin returns, they would be younger than the twin who stayed on Earth. It's like time has its own personal rhythm for each of us. We have practical evidence of time dilation too. GPS satellites orbiting Earth experience time slightly faster than we do on the surface. Engineers have to adjust for this difference, otherwise the GPS system would become inaccurate. It's a real-world example of how, well, time dilation affects our daily lives. So, what does this mean for our future? Understanding time dilation could revolutionize space travel, making it possible to explore distant galaxies. It might even change how we perceive aging and longevity. The possibilities are, quite frankly, mind-boggling.